Visualization. Well, as it relates to visualization in Land Desktop, our options are pretty limited just by the nature of the fact that Land Desktop is not a model-based environment. Instead, it's more lines and arcs and curves of a traditional or a legacy civil application. So, but that being said, there are a number of civil visualization tools on the Civil 3D side, namely analysis tools, that we can use to benefit us on the Land Desktop side until such time as we're ready to move into a model-based solution like Civil 3D. Now, one of the analysis we're going to look at is a site distance check. Another one we're going to look at is zone of visual influence. Now, with both of those, I can perform some analysis that would be otherwise impossible in Land Desktop. As an example, with my project that I have here, I've got a main road that passes from one end of the project to the other, and I want to maintain a particular site distance. I want to be able to see, at least 100 feet in front of me at any point while I'm driving along the roadway. It's a requirement by the reviewing agency for this particular project. At the same time, there is a swale that runs down through this area. I want to see if I set up some signage, what distance that signage is going to be visible with respect to the project that I'm constructing. So now, in looking at both of those, unfortunately, from a Land Desktop perspective, that's going to be virtually impossible. I've got a surface made that represent my existing and my proposed. The contours aren't displayed right now. And I've got some alignments created for my roadways as well as some geometry to represent my parcels. So because I can't perform that form of visual analysis in Land Desktop, I'm going to flip over to the Civil 3D side. And we'll go ahead and just create a new file using the defaults. And I'm going to start by inserting some Land Desktop geometry. Now when I select that, it's going to give me a dialog that I can navigate to the project that I'm in, and in this case it's just the tutorial file. And I'm not going to worry about the description keys, and really the only surfaces I want are the existing and the proposed ground. As far as alignments go, I'm really only interested in the main drive, which is Street A. So you'll see it's going to bring in the alignment geometry as well as the existing and the proposed ground profiles. So we'll say OK. That information gets migrated. And if we zoom extents, we see it displayed on the screen. Now the first thing we notice when we take a look at it is the text is a little difficult to read. However, in Civil 3D it's a dynamic environment. We can just change the scale of our text and that will change or update for us automatically. Now the next thing, my proposed area of grading for my project is in this area, so it is a different surface than the existing, so I'm going to select that and change its properties such that it's displayed more like we would expect to see a traditional proposed. So the contours will be a little bit different, a little brighter on the screen. As a matter of fact, because I'm going to be doing some analysis, I'd kind of like to merge both of these surfaces together, use them as one complete surface or one composite surface for the entire project. We can do that very quickly in Civil 3D just by selecting the existing ground surface, and we will go ahead and paste into it the information contained in the proposed. So when we do that, we've got one complete surface. I may do one other thing here. We'll change my surface properties for the existing such that it too is 1 and 5 foot contour intervals. Alright, now next thing, you'll notice there are some warning symbols that I have here when I get started, and that concerns me a little bit because those warning symbols are indicating that I've got some issues with my alignment geometry. If I hover over the warning symbol, it tells me that I've got a tangency that's been violated, and I've got that in a number of situations along my alignment. So a couple things. I can correct that here. However, that's not going to do me much good if I stay in Land Desktop. It will be something that is going to I'm going to have to take note of when I get back to my Land Desktop. I'm going to have to take a look at that, because if I'm going to have to start making adjustments to the alignment because of tangency issues, my night's going to get an awful lot longer. So from a Civil 3D perspective, it's actually quite easy to fix. We'll go ahead and select the alignment. We'll come into the editor, and if we look at it in the panorama view, we can come down and it highlights it for us those areas that are not tangent or have tangency issues. Primarily we're going to see those on the curves, and in this case we see that all the geometry is fixed. That means everything is fixed points with how it's constructed. We'll typically see that when we have an alignment that was created from polylines. Now, this doesn't have to be out of tangency by a significant amount. If it's out of tangency by even the most minuscule amount, Civil 3D will come up and flag it for us, give us the opportunity to correct it. I can fix it quite easily by coming in and converting my curves from a fixed, 3-point type of a situation to free, where it will take the geometry coming in and out of the curve and force my curve to be tangent to that. So we'll set that to free, and you'll notice that as we start making those corrections, it will automatically start to resolve those issues for us. You'll also notice that when I select them, it's highlighting the geometry for us on the screen, which makes it quite nice if I decide that I want to try something different, or I'm just concerned about where exactly I am along the roadway. I can see that quite easily. So we'll come down and make my next correction. Alright, so with that being said, I've got a clean and tangent alignment. Once again, significantly faster than what I would deal with in Land Desktop. At the same time, my existing and proposed profiles have automatically been updated as well. So once again, if my intent to do this visual analysis is to do it here and take it back to Land Desktop, benefit of staying in Civil 3D or working in Civil 3D is those corrections wouldn't be an issue. In Land Desktop, that's something, once again, I'm going to have to take note of and figure out how I'm going to resolve later. So, first thing I want to do is I've created my composite surface and my alignment. Let's take a look at next. I want to do a sight distance check to see as I drive through this if it's going to affect the placement of any homes, or if my surface-wise, if I'm going to run into some issues. So let's go ahead. We'll begin by creating some layers. And I want to create some layers that I can place some of my visualization analysis on, so it's a little easier to see. So we'll create one here for eye obstructed. We'll create another one here for eye visible. And we'll create one more for eye path. Alright, and just to make them a little bit easier to see, obstructed, we'll set that perhaps to a red. Visible, we will set that to maybe a light blue. And eye path, let's maybe set that to a darker blue. And as a matter of fact, the red, maybe let's go with maybe a little more of a pastel colored. Okay, so I am good with those. We will close out of that. We've got our layers set. If I want to run the analysis, I'm just going to select the alignment, and using the contextual ribbon, I can perform a quick visibility check. So what I'm going to do is I'm going to check my sight distance. And with my sight distance, it's going to have me select my alignment as well as my profile. Now, we brought in the finished grade centerline from Land Desktop, so we'll use that. You'll also see that we can run this on basically any 3D polyline that maybe we've brought over from Land. We'll go from the beginning to the end. We'll check every 20 feet, and the surface we're going to compare it against is the existing ground, because we've made that into a composite that contains both the existing and the proposed. Sight distance, I want to make sure that I can see at least 100 feet in front of me, with my eye height being about 3.5 feet off the ground, and my target height being half a foot above the ground. Final results, let's go ahead. This is where we can set our layers here. So my eye visible, we'll set those. As far as the obstructed, we'll set those to the red. We'll set them, and then I can come back, we'll touch base on them real quick. And then the path itself, we will set that to the dark blue. Alright, so it's going to break the information down. We can control exactly what it is that we wish to see as part of the analysis. You'll notice as we hover over each one, there is within the wizard, there is a heads-up icon that will display for us exactly what it is that setting will control. So visible sight lines will show us whether or not we can see the required distance from those particular points. Obstructed will be those areas that we can't see that far. Eye path, if we're obstructed along the path itself, as well as area, if there's any area that we can't see as a result of the geometry in the surface. What's nice is we can also output this to a report. I'm going to throw this out to a HTML file, and we'll put this on my desktop and we'll call it visual analysis. And we'll go ahead and complete that. And when we do, as we would expect, our design came out quite well. We see our sight lines as we come up and through the project. We're going to be able to see as we work our way across. We have no dark red areas that I can see that may cause me an issue. Now, what's going to be important for me as well is to maintain these sight lines. I'm going to want to bring this geometry back into Land Desktop to see where my houses are currently located or would be located in the future to make sure that I can maintain these sight distances. But at the same time, even though this looks good, let's maybe hop out to the desktop here for just a moment, and let's take a look at the result of our report. So here's our visual analysis. We'll go ahead and open that up. And we see as we go down the list that the violated no, we see at station 289 and 389 were 2 points that actually it was violated, and I could see very close to 100 feet but a little bit short. So those are two areas I would probably want to go back and perform a little more research on the Land Desktop side to see what in my design is causing those areas not to be able to see that far. So with that, maybe just to push some of this back, we can take a look at it quickly. I'm going to select the site analysis. We'll select the center line. And actually at those stations 289 and 389, we can come up and find those 222. We should see a red segment around 289. It might be underneath one of these other ones. Rather than worry about finding it for right now, we would go back and address that in Land anyway. So with those selected, let's go ahead and we'll just isolate that for me on the screen. So we'll isolate those selected objects, and what we'll do is we'll W block that out. Select my objects here, these guys, and we will push that out to my desktop. We'll call this visual. We'll call sightlines. And I can control the drawing file format. I'm going to set it to a AutoCAD 2007 file format so I can use it directly within my Land Desktop 2009. I'm currently working in Civil 3D 2012. So we'll go ahead and save that, and I'm going to set my units to unitless. I'm not worried about any conversion from feet to meters or anything like that. We'll say OK. I'm not going to worry about any map information. We'll hop back into Land Desktop, and let's maybe do an XREF, and we'll see the results of our sightlines. So we'll come down. Here is our sightline file. We'll go ahead and open that up, attach it as a X reference, and we can see now our sight lines within our design. And if we need to maintain the 100-foot that we talked about before, we can see that any structures on these particular lots are going to have to be placed back fairly far for us to be able to maintain that. So that's going to require two things. If that is what they're recommending or reviewing agency is going to require, I'm either going to have to request a variance, or I'm going to have to come back and maybe redo some of the geometry with respect to the parcels that are shown here. So very quickly we're able to do that quick analysis and take a look at that. I'm going to flip back to Civil 3D. We'll go ahead and end the object isolation. I'm going to take these layers and we'll just go ahead and remove them for right now. And let's and here's that. Now that we removed it, 289, there's that segment of red that we wouldn't be able to see or weren't able to see before. So I'd make sure and pull those out and shove that back into Land Desktop as well. A couple other things we can do. It's not going to look the most attractive, but if I wanted to get a feel for how this is going to look visually, I can select it and we'll do a Visionbility Check and we can do a drive. So we'll select the profile for that. We've got the existing and the proposed. We'll use the proposed ground profile. We'll say OK, and we're out in this area. We can set it that I'd like to see what this looks like at driving at 25 miles an hour from one end to the other. There we go. And we'll say maintain the same criteria both for my eye and my target as we drive. So we'll go ahead and click play. And as we run that, We'll flip back to the other end here. Let's play that one more time, and we can see what that looks like as we drive down the roadway on top of our surface. All right, so right now I'm just pretty much looking at rough for mass grading. If I were to get any more sophisticated with my road design in Land Desktop and were to push that out to see a little bit more of the proposed surface, that would certainly become visible and obviously much easier for me to do in this environment than what I would have in Land. One more thing that I'd like to take a look at, we talked about maintaining the sight lines. The other thing was placing maybe some signage along this swale to find out whether or not that was going to be visible. What we can do in Civil 3D, we've got a very nice tool here that's called Zone of Influence. So by selecting the surface, I can come down and do a visibility check, and we can say Zone of Visual Influence. If we hover over that, it will give us some additional information and even a little onboard video within the tooltip to show us how that works. I'm going to select Zone of Visual Influence, and let's say that I was to place a sign in this particular area. Specify height of the object, we'll say 5, be 5 feet high. Radius, let's say I want to go out and check within 500 feet whether or not it can be seen. And when I select that, actually that's going to encompass the majority of my project, but you'll see the X is displayed on the screen as my sign. Any area that's currently marked in green is able to see the entire sign itself. Any part that's marked in yellow is able to see only a portion of the sign, could be the majority of it, but can only see a portion, not the full sign, and any area that's shown in red cannot see the sign at all. All right. Now, keep in mind that these are elevations based on the surface, so there's not an eye height or something like that up on the road. It's actually a point on the ground. So one way that's easier for me to think about Zone of Visual Influence is to think about it more what this can see. So if this is a 5-foot post, this 5-foot post can be seen completely from this area, but the 5-foot post, none of it can see any of the red area, and only some of the post can see some of the area that's marked here in yellow. So if we have something in our project where we need to set a traffic light, or we need to set a, we've done jobs with microwave or cell towers, or we need to set utility poles, and there's some question, wind turbines. There's some question of how far away can we see those, and what is going to be the impact of creating something like that. We could even have something, the vehicles at a stop line, how far can the individual see in relationship to where they are stopped at the stop sign. So tons of uses for that. I could take this as just hatch. I could move that back into the Land Desktop world as well, much the same way as we did before. So with that being said, using visual tools from an analysis perspective, we can certainly use those tools in Civil 3D. We can migrate the results of that analysis and also the report back such that it can be leveraged in Land as a tool. One other thing that I would leave you with is at the point that you're ready to migrate entirely into Civil 3D, one of the things that we have available to us is when the road design is done in this environment as opposed to in Land, we can come up and use the output function to export to Civil View for 3ds Max design. What that will allow us to do is export our complete corridor or our roadway model to 3ds Max design such that we can quickly add vehicles and pavement striping and street lights, create a very realistic photo quality or photorealistic rendering, and also animations of our project. So once again, just wanted to add that to show you how we will build on that from what we've looked at here. So from a Land Desktop perspective, using Civil 3D as a tool, we can leverage some various analysis tools, including the Zone of Visual Influence, Sight Distance Check, and even to some extent the Drive tool. At the point that we're ready to move entirely into Civil 3D, we can begin to leverage a whole host of additional visualization options. So with that being said, that concludes this part of the presentation.